And this would be a good point to save. If I have lost you at this point, you can also go to the day 1 AudioVis folder and start up the first tow file, which basically is the same as we have it here. So if we look back at our particle system, the thing that I kind of want, if I step through this particle system here, disregard all the effects in the front, you see how they're fading out in the background. And this is exactly, it seems like just before they die, they lose their, do they gain transparency or lose transparency?
They gain transparent.
Anyhow, so correct. I need to know how long this particle has been alive, and I probably also want to know how long this particle is gonna live. And with these two values, then I can create a lookup, which a lookup into, like, assign an alpha that depends on the life. Okay. When I middle mouse button click on the particle sub, I get information about certain point attributes of a particle, which is, that's a particle state, life interests me, that's exactly what I needed to get my alpha. So how do I get to this? How do I get to life? I also see the normals here, so this would indicate to me, I assigned the normals via chop2, so I probably can get to life via sub2chop. Like, I can get to the attributes of a sub via the sub2chop. So bring up the upgrade dialog, go to chops, and find the sub2. Again, we can drag this one straight. We can drag the particle sub straight onto the sub2 chop.
Oh, yeah.
And what I get, I see my tx, ty, tz, which is my points. And it's that's the attribute scope, pretty much. If you look at the parameters of the sub2 chop, you will see that the attribute scope is p indicating position. But as said previously, I actually want life. So I'm going to type life in here. So select the sub2 chop, and in the parameter attribute scope, type life. Life, yeah. Which gives me an error.
That's life.
That's life. But what life doesn't have is instructions on what just happened.
Just like in life.
It basically tells you, oh, you've got 2 attribute tokens, but you're providing 3 rename tokens. Like, you're saying you want life, and you say, oh, rename to tx, ty, tz. That won't work. You gotta, like this, there's a mismatch in size, probably. So, okay, life. So I'm going to call this life 1 and life 2 because I've got no clue what these do. If I now look at these 2 lives, then I see, oh, okay, the life 1 is going from 0 to probably, I don't know, above 2. Oh, look, 3, interesting. While life 2 is steady at 3. Somehow this 3 sounds very familiar. If I check back in the particle sub under the life expect on the in the parameters of the particle sub on the particle page, the life expect parameter is set to 3. I can like confirm or verify if I type life expectancy 4 in here, then now I see that my second life channel is suddenly changing to 4, and the life 1 channel is going from 0 to 4. So life 1 seems to be the age, while life 2 is the life expectancy. And maybe I'll rename my channels like this because that's easier. Life 1 is the age, because it goes from 0 to 4, while life 2 is constant 4, and that's the same as I set it in the life parameter of the particle. So I call it age, and let me see what I named it before. Yeah, or let's call it lifetime. If you, Ben was mentioning the life variance, you can very nicely see now what these parameters, these life-related parameters do. If I set life variance to 1, now you see that my lifetime is somewhere between 3 and 5, meaning life variance gives you a delta of up and down of 1 second. Life expect is 4, plus minus 1 variance. So if you read the information here, it tells me that this v thing, which it might be velocity actually, the v is has 3 values. Particle state is 1 value, and life has 2 values, and normals is 3 values. So that's the brackets in the back. It's a typical, if you encounter that somewhere, it's often the typical like list or array kind of. I think that's the same must be the same in processing and all other programming scripting languages.
So when you write life, you could also write n or v and then whatever after.
Correct. Yeah, and you can get more out of this. It's not just life that you can get out of here. You can also, if you put the n in here for normals. It's now complaining again because I don't have names specified, and 1 and 2 and 3. Now you get the life-related attributes plus all the normals as well. So you could get all the information available. So the error, if you middle mouse click on the error, it should tell you about what, like a little bit, what's happening. Mine, I assume you have the same error. It would be 8 attribute tokens and 7 rename tokens. So there's a mismatch in how many things I'm requesting and how many things I'm naming.
And how do you see the difference? Now you put a lot of parameters, and how do you see the difference in behavior?
Right, so this is not behavior based. This is just, I'm just looking at information.
Okay.
Yeah. I can see a difference. I can monitor behavior in here. Just gonna go back to where I was. That was what I meant to show with the life variance here. If I set the life variance to 0, you see that lifetime, except for the particles that won't die, is at a constant level, and my my age is again circling between 0 and the lifetime. When I see these kind of things like these spikes, Ben was mentioning that earlier as well, I can reset my particle system. I can also turn on this remove unused points, which I find helps on the parameters of the particle page. Okay, so we've got age and lifetime. Now, I want to assign that to an alpha. If I want to put this onto an alpha, let's say like a linear one. When they're born, they're alpha 1, and when they die, they're alpha 0. So how do I divide this? Division is pretty basic math. So right-click on the output of the sub2 and find the math chop. And yeah, you have 2 channels that you want to divide, and And there is a combine channels here. So in the math job with the combining the channels gives you the option to add, subtract, multiply, divide. Greg earlier showed the length to calculate length between two positions. And so, yeah, we want to divide. The age looks very similar to the age here, except that this age is between 0 and 4, and this age is between 0 and 1. Now, I could say, oh, okay, well, you've got 0 to 4. Why don't you just rearrange, like multiply or divide by a quarter or something like this? That's very simple to answer because I'm going to change my life expectancy here, or other people might have a life variance where I don't have this one divisor that I could use. Here, I need age and lifetime to get my 0 to 1. Okay, I'm going to clean up a little bit, just move stuff a little bit to the side. So that's good. After the math, I'll add a null, because I always add a null. This age I want to apply to alpha. How can I do this? I need to assign for every particle, for every point in the particle, I want to have it its own alpha and grab it from this list here. Earlier we looked at how we could maybe assign normals. We found that in the point sub I could do this. So maybe I can assign color or alpha, which is part of color, also via the job 2, right? Like the same way we assign the normals. So I'm going to right-click on the particle sub and get again a job 2. Sub. Previously I assigned normals, now I want to assign color, or specifically alpha. So I can drag again the null onto the job, and my channel scope is all wrong. The channel that comes in is called age. So my channel scope, I just will click into the parameter and select age. Now it's doing funky things because what's happening is that my age is actually overriding P0. P0 being position in X. I don't want that. I want to get color. So in the attribute scope, you can again click back here on the little menu. And if you look down, you get position, and then the second entry already is color. And specifically, I get point color alpha. And I don't see anything. Now, there's a good reason why I don't see anything, because when the particles are born, the alpha is 0, and only when they slow down and basically disappear will they reach 1 for a short moment. So maybe I have to change the way that it's going from 0 to 1. Like my 0 to 1 maybe should be 1 to 0. And maybe it should not be just linear, because that sometimes is ugly. Maybe it should be a nice, like, curve. And this is where a lookup comes in. I don't know if Greg did a lookup, I believe. So the first step would be for me to create the curve that I want the alpha to fall off with. And a nice way to create these curves is with a pattern chop. So I'm going to bring up the Create dialog, go onto the chop menu, or chop family, and select the pattern chop. The pattern chop makes it easy to create all kinds of different waveforms, and it's easy to shape them, and you don't need to do too much. Like, you have lots of options to shape the waveform. So in the curve in alpha, what I'm looking for for my alpha, what I'm looking for in this, I basically want a portion of this curve here. I want here, when they're born, they should be 1, and then they should fall off down to some other value. Currently, it's -1, but the pattern shop gives me all the parameters to actually shape this. For example, I could start playing around with number of cycles. Okay, that's great. Now, I'm not sure, usually, especially when you're working with sines, cosines, and all that stuff, all the interesting values are 0.5, 0.25, something like regular. So my number of cycles I'm just going to set to 0.5 here. And now if I shift the phase of a sine wave, then I go through the whole sine wave and I get exactly to that point where this curve looks pretty good. I've got 1, and then it nicely goes into a slope down, and then it like does that thing here. It's not too linear. And my value is close to -0.25. So my number of cycles on this default pattern shop would be 0.5, and my phase -0.25. Now with alpha, alpha can be 1 to 0, but -1 sounds a little bit funky. So luckily, the pattern shop supplies me with a from range to range, which should be familiar from the math shop. So I can specify my beginning range, which is, I see here, it's -1 to 1. And I can say what this range should be remapped to. So 0 to 1. So from range -1 to 1 becomes 0 to 1. And I end up with what I wanted. Like I have a nice curve. Now I just somehow have to tell each of these, what's currently this linear rising H channel, I now somehow have to tell it to not take this linear value, but take the nice value from the channel 1. And this you can do with a lookup. Now, lookup tables are something that you're going to come across everywhere. What the idea of a lookup is, like I have my curve, my pattern is a curve, and then for each, I'm going to stop this here, each of these channels here in the math, each of these samples in the math has a certain value. So for example, this is the value 0.5 for this sample here. Now, because everything is nicely between 0 and 1 in most cases, this 0.5 with a lookup could be right here in the middle of this curve. If I look at 0.3, then 0.3 from the beginning would be somewhere, I don't know, I guess here in the graph. 0.6 here, 1 here, 0 here. That's what a lookup does. This 0 value is going to become 1. This 1 value is going to become 0. This value here, which is 0.19, is going to be somewhere here. So, okay, I'm going to right-click on the output of the math2 and select the lookup chop. And the lookup chop is has two inputs. The first is the index, and the second one is the lookup table. In this case, the pattern will be my lookup table. So I'll connect the pattern into the second input of the lookup. Now my chop2 actually comes up with a warning, and that is because my index is not anymore what I called H before, is now suddenly the channel, the null 2 here, is not called H anymore, but it's called Chen 1, just like this channel here. So I will go to the pattern chop, select the pattern chop, and in the parameters go to the channel page and name it H. Yeah, so that the chop 2 again has the right, because the chop 2 expects an H channel. Okay, there's one more thing here. And that's something you will discover, and that's something where you have to try stuff. By assigning the alpha to the point color, you see in the chop 2 you see that there's now a CD, which is the attribute short for the point color. If you go into particle and middle mouse click, that is missing. Now I'm just assigning alpha, but it assigns the full attribute of color, which means RGB is going to be black, and we only assign alpha, and that's why the particles currently are black and then fade out. So to fix this, we could add in a point sub to add the initial attribute for each point, like to give it a color for each point. Now, and this is a performance thing here, which is important for subs, especially because subs can get slow. You can tell from the lines here that like this node is cooking and this node is cooking because the lines here are moving. But here the lines are totally static, so there's nothing happening. Those nodes are set up once and then they're happy, then they don't cook anymore. So it would be interesting, any nodes that that don't need to be animated, to put into the beginning where they don't do anything anymore. Like, for example, this particle sub currently takes 10 milliseconds here. No, 1, 2, 3, whatever. So don't do this, what I'm doing now. I just want to show you the difference. I'm going to add a point sub in here. And we will be repeating one of these steps. So now my particles are white again because I added color to it. And if you look at the point sub now, it's 0.26 milliseconds, which is not too much. But once we add more particles, I'll just add more particles. Let's see, birth. Okay, I'm now creating 40,000 particles here. I have currently 40,000 particles, which brings this point sub, suddenly the point sub takes up 1 full frame almost. Now, amazingly, this point color attribute doesn't have to animate because I'm just assigning a color to something like that's going to be copied downstream. So if I put it here in the beginning, I have the same effect. My particles are white, but this point sub is not cooking. It only cooked once. That's it. It doesn't cook anymore. You don't see this changing. You don't see the total cooks number changing. This is not going to impact your performance anymore. So I'm going to set my particles back to something normal. So what you get is particles that fade out from white into transparent. So this is a good time to save. And if I've lost you, there is an audio with 02 that you can basically see the same network.